Hi students, today we are at lesson 4 on the particular model of metal. So let's do a quick recap from last lesson. So last lesson we investigate 4 properties of solid, liquid and gas. They are fixed, whether they have a fixed shape, can they be compressed, do they have a fixed volume, and their density. So for the fixed shape, right, only solid has a fixed shape, and the reason being right is because it has a strong forces of attraction. So when there are strong forces of attraction, this sort of like confine the particles right in its position in a very orderly fashion. So that's why when they move right by vibrating around its fixed position, it wouldn't like change the shape so much. That's why it has a fixed shape. So one of your classmates asked me, right, what does it mean by forces of attraction? Okay, so you can treat these particles, right, as a magnet like that. So each of them, they will be able to attract the nearby particles. So this attraction, right, is called a forces of attraction. They will try to like attract one another. So the closer they are toward one another, like a magnet, the stronger it is the forces of attraction. So this is what you mean by forces of attraction. So for liquid and gas, right, the forces of attraction is very weak because they are slightly further apart from solid. So this causes them to try to have a disorderly arrangement whereby the liquid are like very like less orderly than the solid. While for gas, right, gas is also like less orderly than the solid also. So due to that, that's why the liquid, right, they can slide about one another, slide. And for gas, right, they can like move in all directions very rapidly. That's why they don't have a fixed shape. And for whether they can be compressed, right, solid and liquid cannot be compressed is because we know that they are packed quite close to one another. That's why it cannot be compressed. While for gas, right, they are very far apart from one another. That's why in the middle, right, the distance between the particles is very far apart, and this resulted in a very large amount of empty space in the middle. So that's why when you're trying to compress them, right, you can do so because you can push them towards the empty space in the middle. This explains why they can be compressed. And compressed and fixed volume always go hand in hand. When something can be compressed, there's no fixed volume. When something cannot be compressed, there is fixed volume. And for density wise, solid has a high density, while for gas has a low density. So density means, right, the amount of a substance present in a fixed space. So let's imagine we have like 10 particles in this small circle over here, small circle, as compared to 5 particles in this small circle over here. So for the 10 circles, right, when we have more circles or more particles, it will result in a larger mass. When we have little amount of particles, it will result in a lower mass. So density is mass divided by volume. So when mass is higher within a fixed space, which result in a fixed volume, larger mass divided by a fixed volume will result in a higher density as compared to a lower mass divided by a fixed volume. So today, let's move on to our main lesson of the day. So today, we'll be looking at expansion and contraction. And the question of the day will be two kinds. What happened to the particles of the metal during expansion or contraction? And why do we use a model? So you can copy these questions onto your post-it and paste on page 8. So when you revise your notes, right, at least you can know like which part to zoom in on. Okay, so some application in daily life. Have you ever wondered, right, why the hot air balloon, right, can go up when you turn on the flame inside this balloon, and it can like go down when you turn off the flame in this balloon? So what is happening over there? And have you ever seen, or like someone told you that whenever a cup is stuck, right, you try to heat up the cup that's outside so that you can like release the two cup or separate them like from one another. So these concepts over here, right, is actually using expansion and contraction. So we'll be learning that today to explain this daily life application so that when you go to these places or when you saw video of them, you're like, oh, I know what happened. It's because of expansion and contraction. So let's go through some like brief introduction on what is expansion and contraction. I believe we have some key learning point from primary school, but we'll like recap again. So for expansion, right, and contraction, when a metal gain or lose heat, this causes the change in the movement of particles and the arrangement of particles as well, which result in expansion and contraction. So what is expansion? Expansion occurs when an object increases in volume without a change in mass. So what does it mean? So imagine, right, you have a small room with like 9 people inside. So when you do an expansion, right, you increase in volume. So now we have a bigger room, but there are still 9 people inside. So this is the meaning of expansion. You increase in volume, increase the space, but the mass still remains the same because there are still like 9 people inside. For contraction, right, you think it of like you have a bigger room, and now, right, you decrease in volume, which means you decrease in space. The amount of people inside, right, like still 9 people in a bigger room. Now it reduces to a smaller room with 9 people inside. So this is the meaning of contraction. Contraction occurs when an object decreases in volume without a change in mass. So what happened during expansion? So this one is a diagram to show you what actually happened. So when the heat is applied to the solid over here, particles gain heat energy and become more energetic. So you can think of like, we are becoming more energetic, so you can like move more faster, move more rapidly, or like move with more energy. So they will start. So for particles in solid state, right, they vibrate more vigorously. That means they are more faster with more energy. So in this case, right, the particles will be able to move slightly further apart from one another, as shown in this picture over here. Now they are like more further apart from one another, and this also increases the volume of the solid. So when they move further apart, we result in a larger triangle, a larger rectangle, which means, right, we have a larger space being occupied. So this process is called expansion. So for contraction, right, it happens when an object is cooled down. So you can think it as like we have a bigger room, inside got 9 people. Now we try to like do a contraction, we contracts. So now we have a smaller room, but still 9 people inside. So this is the meaning of contraction. The amount of space decreases, but the mass didn't change. So when the object is cool, particles tend to lose heat energy and vibrate less vigorously. So at first it's like that, very fast. Then after that, when you lose heat, right, you start to go slower, 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 and slower, and slower. And due to this effect, right, particles now move closely to one another, as you can see in this diagram. At first, it's very far apart a bit. Now it's like closer to one another. And this result in the volume of the solid decrease, because you now see, right, the particles now occupy a smaller space. So volume and space, right, is the same thing. So this process is called contraction. So during expansion and contraction, the main key point is that the mass of matter does not change, as the number of particles in the object still remain the same. So it's the same idea of like 9 people in a bigger room now reduces or downgrade to a smaller room with 9 people also. The mass of the person doesn't change because we have 9 people from the start, 9 people after that. So the mass doesn't change. So let's do a quick checkpoint as we have reached the end of expansion and contraction. So when temperature increase, right, what will happen to the particles in the metal? The particles in the metal will become larger in size. The particles in metal will move with greater speed, move with smaller speed, or move with the same speed. So what do you think? So you pause the video, think about it, and once you have write down your answer, you can continue the video. So as we mentioned, the particles in the metal will move with a greater speed because it's like more energetic, gain more energy, so it will move very fast. It's like your energy bar suddenly increases, so you now have more energy to like do more things. So that's why you move with greater speed. So for checkpoint 3, right, which of the following about particles is or are true? So when you see is or are true, right, it means, right, there can be one or more than one statement that can be true. The particles are always moving in random direction. The particles do not move. The particles are always moving in a fixed direction. So in this case, right, the answer is 1 only. The particles are always moving in a random direction. And 2 and 3 is out. So let's look at the last question of the day. Model as representation of phenomenon. So this one is actually a recap from chapter 6, whereby we talk about cells and we are using models, right, to talk about and investigate about the cells. So models are actually just representation of like phenomenon constructed to facilitate understanding of what are the process and the structure that cannot be observed or directly or to make reasonable prediction. So that's why we use a model to help us understand the things around us. So why do we need to use model, right, to study about particles of metal? So particles of metal are actually very, 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 very small, which cannot be seen by our human eyes. So that's why you need to come up with model. Like, so what is model, right? Let me show you some example. Okay, so this diagram over here are, are some example of model that we use to understand the particles in a different state. So that's why we need to use model to help us understand the things around us because they are too small to be seen by our naked eyes. So please copy this part into your notes on page 12. So what are the aspects about atoms, right, that cause them to be presented as circle in the square box? So why do we use a circle? Why we cannot use triangle, square, or rectangle? So what will happen if we use this shape, right, to represent particles? Okay, so the main idea, right, is that circle, right, is easier to draw, and circle doesn't have like pointed edge, which causes them to be. So when you have a lot of different triangles, right, triangles can have like this orientation, that orientation, that direction, so many different type of orientation. So this also means, right, these particles that are like completely like different. So that's why you use a circle. So no matter how you change it, right, it will still be in the same manner. Okay, so as a recall, models, right, are actually just approximation of the actual phenomenon, and they can be like inaccurate sometimes. So that's why, right, model of phenomenon, we keep on changing as we understand more things, and we try to like come up with a better model, right, to represent and explain certain phenomena. So now can you think of other ways, right, to represent what you have learned about particles in the tree state with other models that you have seen in your daily life? Okay, so for example, so previously I used the example of like a classroom sitting arrangement, whereby how the students are being like positioned in the classroom. So in the classroom, all of you have like low energy because you're sitting at your own space. You cannot like move about. You're because of sort of like being restricted. So this represent like a solid state, the particles in solid state. So during recess time, right, all you are able to like move freely, but you cannot move too fast also because there are like too many people. So this represent a packed diagram. The people are able to like move freely. It means the particles are able to move freely, but they cannot like move too fast also. So this represents like the some particles in a liquid state. And for PE lesson, it represents the particles in the gas state. Because during PE lessons, right, you can move wherever you want. For example, you play soccer, right, you can move wherever you want. There's no one will stop you like to run about unless it's a dangerous situation. So these three different lessons, right, actually represents, right, solid, liquid, and gas. So models actually help us, right, to link our daily life applications, right, to things that we cannot like explain by our naked eyes. So this is the usefulness of model. So before you come back to school next week, I need you to ensure that you have do all these like questions so that we can go through in class. So for lesson 1, I've asked you all to do this question over here. So make sure that you have complete it. And this one is the question for lesson 3. And some additional homework. So before the holidays, before your not holiday, before your home-based learning start, right? I've assigned you to do your 2019 common test paper as a revision. Because it consists of chapters from chapter 1 to 3. And I only need you to do it so that I can collect back to Mark next week. And we can go through in class. So for science workbook, this one is the new questions. I only need to do these 5 questions, which touch on expansion and contraction. So to give it a try, we'll go through next week also. Okay, so to reward you for watching this entire video, I'll reward you with a pun. So how to cut the C into half? So if you want to cut the C into half, you need to make use of a seesaw. Get it? Okay, I believe some of you get it. Some of you need a little bit more time in understanding it. I hope you understand or like can get some laughter from this pun. Yes. So if you have any questions regarding your workbook question, right, you can just drop me a text. I'll try to like reply when I'm available. Cause there are still lessons, right, ongoing in school while you're having home-based learning. So thank you.